Hello guys, welcome to class 15 of Python programming. We'll discuss about generators today. Let me write a function here. The name of the function is fun. Then I have to write colon. Let me write colon here. Then let me write a is equal to 10, 20, 10, 20, 30, 40, 50, 60. This is a list here. Then I'll write a for loop for I in a print I. Now let me call this function. So it's not that we have not seen this kind of a function before, but I have a different reason why I wrote this function. See here, when we are calling the function, the control goes here, then the list is defined, and then after this assignment statement, whenever you write a for loop here, for I in a, whatever is there in a, it will be printed. So you get print out all this. I can change this one a bit. Suppose I'll write it this way. Instead of defining this one, assigning this one, I can write within the function definition for I in range. I'm writing 10 here. We'll do it 1000 later. So then for I in range 10, we don't need to write all this. Even we'll make it a, that is better. And you send a here, that way it will be variable. And then you print I. So this is the function here. It will take 1. Suppose I'll send 10 here. You run it. So I got 0, 1 up to 9. How about this? I got 10, 20, 30, 40, 50, 60. So when we talk about a list, 1, 2, 3, 4, 5, 6 are here. So we got the printout here. And we have 10 here. So A is 10 here. And you got 0 to 9. Okay, so it's working fine. Now replace print by return. You run it. You check what you are getting. See the output here. And change this one with return. See the output. We got only one output because return should be the last statement here. What happened is when I call the function with 10 here, I send 10 here to A. So I receive 10, A is assigned to 10, and for I in range 10, the initial value of I will be 0. You can write I is equal to 0. Then what will happen? It will return I. Then that ends here automatically, because once return statement comes, after that whatever you write, that will not be executed. That's how you got 0. Here even 10 is here, the first one. will not get any other. So if you want to have a for loop here within function, whatever way it is, make it sure not to write return. If you want to get, you have to write print, so that you will get all. You will not be able to return everything. You will be able to return one. If you can even return two, there is a different way. I must have discussed this one in the earlier video. I mean, in the previous classes, so I'm not going to those things now. Our subject is generated today. Now, what I want to do is, I would like to change this one to yield, yield. Remember. Then what? Then it gives generator object. I wanted to check. There is no need to check. It says this function is a generator type. What is the print? I mean, what is that you got? You didn't get any answer here. Okay. Now go to this one. When you change this one to yield, then if you try to run this one, then you got generator object function at this. So finally, this is generator object. Okay. So what is the usefulness of this one? Let me write here. Generator iterator, or you can write generators are iterators. So how can you get iterators from iterables? This is one iterable. List is an iterable. So from iterables you can get iterators. From generators also you can get iterators. Because this is a generator, this is also an iterator. This is also an iterator. So how iterator can help? What is the benefit? You give some name here, A. Then because A is an iterator, you write next A. You got 10. Then you write another next. Continue writing. I have to write print though. So what will happen? I will try to print one at a time. What is the benefit of printing one at a time? Sometimes you get infinite loops. What will happen is, if you run a for loop or a while loop, you will get infinite loops. But if you have a generator object, you don't get infinite. It's lazy. Because it's an iterator, it's lazy type. What will happen is, you get one at a time. It's better to get one at a time. You go somewhere, you wanted something to purchase, you get everything at a time, it's very difficult to keep. If you get one at a time, it will be easier for you in terms of space, in terms of whatever you say, though it will be a bit lazy kind of a thing, but then it will be good for you. Here also, suppose you want to get one at a time up to 60, you write another one. You write another one, then there will be a problem. So I'll discuss this one later. We can even Make this kind of a thing. Remember, it will stop once you cross the limit. Run it and everything is fine. But remember, you get one at a time. That is the benefit. I'll take you to one of my classes where even here I can copy this one. This is a recap. Suppose if I write next B here, if I write next B here, I'm not getting anything. Name B is not defined. Name B is not defined. And number two, okay, this is a comment anyway. Then when I wrote next B, I'm not getting the desired result because list is not itself an iterator. So if some sources you come to know, because in many places it said that it's an iterator, it's not an iterator, it's an iterable. But generators are iterators directly. See, we are not making an iterator out of generator because generators are iterators itself. This goes this, I can write also here generator. Generator is an iterator. Then generator is an iterator. Then what will happen? Let me write generator and iterator. Then iterables, from iterables you can get iterators. I can write iterables here. Iterable is an iterator. But you will not get directly. Let me cut here and paste here. I mean, there is always a confusion when it comes to these things. So what will happen is, if you have a iterator, you don't directly get from iterable an iterator. So I can show you this way. Okay. So if you see this one, from iterable, you don't get iterator directly. So there is one iter method. Through iter method, you get an iterator. From iterable, if you want to come, you have to apply iter method. Then you get iterator. Then one by one element you can get. You'll be able to know what is the benefit of getting one element at a time. But I'll not go to those things in details now. Not required. Just remember, from iterable, you will get iterator after applying iter method. But generators are iterators. So A is 10, 20, 30, 40. It will not work. You have to, okay. There was another problem though. I should have written B here. Yeah, there is a problem anyway. Now we'll write C, iter B. C is iter B. Then if you check, if you want, you can check type of C and type of B as well. This is list iterator. Okay. You have to type both. So you can turn this to an iterator. See, this is class list only, which is an iterable, but now you got an iterator. If you have doubts here, you can go through my previous videos where I explained fully in one class regarding iterators and iterables. Remember, C is now an iterator. So we can apply next C. Try writing next C, copy, paste here, run it. So we got 1. But why? Yeah, we got 10 here. You have to write print statement. That's what. Yeah, we got. Then continue printing. One by one you are getting. So from list you are getting one by one. If you write an iter method, this is not new. We discussed already this one. Coming back to this, you need not apply iter method here. Remember the keyword? It's a function with your print statement or return statement replaced by yield. This is the only thing you need to remember. So you get a iterator here. This A is an iterator. Now you can apply next method one by one. Then you can get all thing. Similarly, this one also, you need not apply iter method because generators are iterators directly. So I can write here D suppose, then you can write print statement, run here. Okay, we got 0. One. Then if you run, you get 2 here, 3 here, 4 here. That way, you will continue to get one by one. Now, because we have numbers up to 9, 0 to 9, then it's fine. Suppose I have 1000 numbers and you need only 3. If you write a for loop and you write a print statement here, it will print everything 0 to 999. So that is a waste of space. Suppose you need only 3. For only 3, why you print 1000? It's like there are 1000 students in a particular college. You need only 3. So you call everyone to the college. Then you say 997 are not required. Only 3 are required. The first 3 are required. Everyone can go. That way here also, you want to use the first 3 or 4, but for that you are printing all 1000. It's unnecessary. So that is the reason, if you have a generator, whenever you want, because it's an iterator, ultimately we get a iterator. That iterator will give you one element at a time. That is the benefit here. So you get one element at a time. Continue, right? Even if you have written 1000 here, continue printing one by one, whatever you want, then that will be fine. Let me write another function. fin, name of the function, and colon here. Then I will use this one, if true. I will write a for loop for I in print I, then I will call this function. Okay, let me write here a, or maybe I've written already, whatever. You run it, check whether it's working or not. So takes zero positional arguments, but one was given. Okay, so better you write E here. So you know E, right? Okay. So I got 0 to 9 once again. See the difference between this and this one and this one. Here also we have written a for loop, okay? Yield with yield. Here we'll change it to yield later, but I've written print. I wanted to get everything 0, 1, 2, 3, 4, 5, 6, all that. Even another thing, if you write a function, you can get many, you can write many yields. Even that's what we are writing here. Yield I. When you write yield I, then how you are getting? Because when you get yield I, after that you are getting one by one, right? Every time. Come to this one. If you don't know about this, let me tell you. If true, when you write if true, then every time this will be executed. Every time this will be, whatever you write, that will be executed. I can make it a infinite loop also. If you just write pass here, then it will be infinite. Even if it's finite, I've given 10 or 1000 or 100. See the difference between this and this. Here we have a function, here also we have a function. Here we have a for loop, here we have a for loop. But here what I've written is there is no such if clause. Here if you say if true, then for I in range this one, I've written this one for a specific reason, because I want to, I mean, later I will have a chance to give an alternative. Here there is no alternative. So I want everything to happen. That's why I've written true. Otherwise, you can give any condition. Suppose you want to say, uh, you if is, I'll send 10 here. You write if is greater than 10, then don't do it. Okay. So, or maybe do it. Otherwise, you don't do it. Those things you can write here. I'm not going to that. I want to make it simple. Here also, if you change it to yield, then the same thing. Then you give a name to this one, G, then just write print next G. One at a time. You get one at a time. Whatever way you write, you get one at a time. That is the benefit. Next one, I want you to print. This has no link with generator functions. Once we see these kind of problems, we think that we have some pattern. We have to make a function because we are in functions. And this is one of the problems. I wanted to write this. Remember, I discussed before um, one way how to get star, double star, triple star, and all that. But sometimes it becomes easy. If you want to get a output like this, then we can write this way. For A in range, suppose I will write 5 here. 10 times of n plus 1, that is 11, right? So what will happen? You run this one. So the benefit here is we wanted to print this one and then multiply it by 10, then add 1. So what will happen is 1 will become 11, but second time a in range 5. So when n is 11 here, so 11 into 10, 110 plus 1, that will be 111. Okay, it's so easy. If you write 10 here, you get this way. This is a small program. So you have to see these kind of relations also. Because sometimes we need to write two for nested for loops, like two for loops, one under another, then you get these kind of shapes. But here, if you have numbers, you can do different way also. Now, suppose I change this to yield, then what? Will it work? Yield outside the function. Yield outside the function. Yield will not work here. That's why before writing this one, I I said you see this is no link with generator. Particularly, I've chosen this problem to make it sure that whenever you consider yield here, you you have to make it sure that you are not using yield outside the function, okay, in a for loop. Now I'll write the last example for today's class. Let me write another function. Any number, suppose a number is 0, then while true, the last line is number plus 1. So we write in Python plus is equal to. So what will happen is if you run this one with a print statement, while true, yield number, then increment number. So it will continue. It will be infinite loop. So what you can do is you can call the function, but here we have written yield, so it will not be infinite one, but you can get one by one. Suppose I write m here, run it. Then when I write print next m, you run it, you got 0. Got 1. So continue. It's a while loop. So what will happen? Oh, all right. This is another one. So you got 1 here. Continue. So when you talk about such kind of an infinite loop, then with the help of a yield function, we get 1 at a time. Whenever you want, continue writing next and you get 1 by 1. Till your heart's content, you get 1,000, 10,000, 1 crore, whatever you want. Continue writing 1 1. See, only with writing, we're replacing print by yield changes things a lot, because the one we got here m, it's a generator which is an iterator. So we say generator iterator. That's all for today's class. Thank you. Class is over now.